On December 15, 1989, KLM Flight 867 was en route to Tokyo from the Netherlands when it inadvertently passed through the ash cloud generated by the new eruption of Mount Redoubt in Alaska. As ash interacted with the airplane's engines, it was heated at glass, triggering an automatic shutdown of all 4 of its engines. The crew quickly tried restarting the engines, but it was useless due to the damage. Then, miraculously, all 4 engines restarted and the plane landed safely in Anchorage. What had just occurred could have been deadly, as even negligible amounts of airborne ash can easily cause engines to burst into flame, downing aircraft. In total, $80 million in damage occurred to the airplane. This incident, along with others, led to the creation of the Volcanic Ash Advisory Network, which would warn pilots away from future ash plumes. Thus, you might think that the network only needs to monitor actively erupting volcanoes, as only ongoing eruptions produce large volumes of ash. However, this is not the case. A volcano does not need to be erupting to potentially damage and down an aircraft, and I am not talking about the threat of collisions. Take, for example, this satellite photo on October 5, 2014. It shows a plume of ash that rose to a height of 4,000 to 6,000 feet, which then drifted to the east-southeast. This ash plume originated from Katmai National Park. Yet, this park has not produced a single volcanic eruption since 2006, and this column of ash did not represent a new eruption. Rather, it represented resuspended ash which was originally deposited in the largest volcanic eruption on the planet since Krakatoa exploded in 1883. In 1912, the Novarupta volcano ejected 30 cubic kilometers of tephra, which deposited a thick layer of ash and pyroclastic flow deposits. For comparison, this 60-hour-long eruption was 30 times larger than the famous 1980 eruption of Mount St. Helens. The reason why the Novarupta region occasionally resuspends large volumes of ash relates to several factors. The most important factor is a lack of vegetation in the subarctic climate. Much of the resuspended ash originates from the so-called Valley of 10,000 Smokes. This area formed through dense pyroclastic flow deposits which are still largely unvegetated. Due to the lack of vegetation, the loose tuff has not become hardened. The aforementioned deposits also have low soil moisture. Third, the area frequently experiences high winds. During intense windstorms, a cascade effect occurs in the top layer of ash, causing additional particulates to become suspended in air. Fourth, the area which experienced the majority of ashfall during the large eruption of 1912 actually is a landmass and not, say, an ocean. This is why the Hunga Ha'apai volcano has not produced a similar phenomena, as only a negligible amount of land was covered in a thick coating of ash. So, if you see a volcanic ash advisory originating from either Novarupta or Katmai volcanoes in Alaska, the odds are that they did not unexpectedly erupt, but instead a large volume of ash was resuspended due to strong winds. Pilots often have to avoid the area due to these resuspended clouds of ash, which typically occur several times a year. Other volcanoes outside of Alaska exist with a similar phenomenon, but none have continued to produce ash clouds like Novarupta more than 100 years after their eruption. Thanks for watching. If you would like to request a specific topic, please leave a comment below. Additionally, I would like to thank my new patron Janessa Murray for supporting this channel.